Hi, today we are going to see the topic on JDK, JRE, and JVM. This provides the pillars for the Java ecosystems. What are they, how they are going to work, how they are going to differ, we are going to see in the upcoming slides. In the last class, we have seen the different platforms of Java, the features of Java. In today's class, we are going to see more about what is JVM and what is its architectures. JVM stands for the Java Virtual Machines. So it's an abstract machine. So as I told, whenever a Java program is loaded, it converts into one bytecodes. So that bytecode is it's a machine independent. So that bytecode can be executed in any of the platforms. So that kind of support is provided by the Java Virtual Machines. As can see, it's an abstract machine, a specification that provides a runtime environment for executing Java bytecode. It can also run programs written in other languages compiled to Java bytecode. Okay, so this is where the advantage of the JVM comes into pictures. First, the dot class will be loaded. Then our JVM is going to verify for its correctness and security. Then the code gets executed. Then our runtime environment gets into features. It manages memories, threads, and the garbage collections. This is the main task of the JVM. Then JRE. What is JRE? JRE stands for Java Runtime Environment. It's a stuff of a lot of library functions which is available when you install the Java applications, which are the versions you're going to install. If you're installing a Java 8 or a Java 9 or Java 11 or Java 17 or the latest versions, you have to have the JRE of the specific versions. This comes inbuilt when you install Java software into a systems, into a laptop or into a desktops. But what is the purpose of this? It is a physical implementation of the JVM. JR is a physical implementation of JVM. It provides everything needed to run Java applications, but not to develop them. Okay, so it is not possible for me to develop one more JRE. JRE is it's like a physical device which gives me a virtual machine to run over Java codes. So this JRE physically exists. Unlike the JVM, JR is an installable software packages. As I told, in the many versions of Java you want to install. Say for example, I've installed my JDK 17 into my Windows 11 PC. We can see here the folder gets created Java over here, and I have a JDK 11 and JDK 17 also. If I go to JDK 17 here, we have some libraries. Okay, in these libraries, we are going to see some of the important files. If you go back, we have a bin folder here. You can see these are all the application wherever you have this application kind of things. These are all the files which are unexecutable files. So you can see a jar file over here. Okay, right? So similarly, there are some JRE files which are also needed to run our applications that to be configured over there. Okay, even that is going to come when you configure this your Java software. Okay, generally you will be getting one more folder. You had to be there called uh, here you don't have the JRE separate over there. If you go to JDK 11 or just a minute, let us say in the bin folder, these are all the DL files you can see over there. So those can be the files which are also needed for executing your applications. Okay, so some of the RAR files, I can say we have a JAR files, JR files. Those JR files will be there in the JRE. Okay, right? So some JAR files which are for the fundamental programs will be available. For example, if you're connecting your Java to backend database like MySQL or MongoDB, you have to download the jar file and you have to configure with the corresponding jar over there. Okay, so in the Eclipse, I just show in the Eclipse IDE. If I open my Eclipse IDE here, okay, just wait for a few minutes, it gets loaded. So whenever you create a project using Eclipse IDE, it is going to ask you to configure the JDK versions. By default, it is going to take the latest versions. But what are the versions you are having in your laptop? Whatever versions you are installed. For example, I have JDK 11 and JDK 17. So because I use JDK 17, Java 17 to my projects, so I'm restricting myself to Java JDK 17. I'm not moved on to the latest versions. Now, when I go to my Eclipse IDE, you can see there uh, uh, in the project folder. Okay, so this is one folder, one project, college app. Okay, so if you just right click, if you expand that or right click on the project name, okay, you go to this option called build path. Okay, here, go to build path. Okay, it's taking, okay, configure build path. Click on this. So once you click on this, one more window gets open. You can see your JRE system libraries. Okay, so these are all the libraries which is available for us. Okay, to execute our Java applications. If you wanted to install any third-party jar files, you have to configure you have to go to this location and you have to change accordingly over there. Okay, so this is called the JRE files. Okay, so let us come back to our presentation. Okay, right here. So the JRE is a installable software packages. Okay, as I told, if you want to connect to a MySQL connector, the connector jar file is going to come. So those jar files has to be configured with the JRE applications. It contains a lot of libraries, as just now I told. For end user, if you only need to run Java apps, JRE is all you need. Yes, we can convert finally into a jar file. At the end of the sessions, we'll be showing how do we convert if you want to deploy on the cloud or something. You need to have a jar file. So how to create a jar file also, I'll be explaining you in the future classes. So what is JDK? JDK is a Java development kit. It's a combination of JRE and development tools. Whenever, as I told, the JDK gets installed, okay, we can write the program, compile the program, and debug the programs. As we discussed in the last class also, as we have here three editions, three platforms: Java Software Editions for desktop applications, Java Enterprise Editions for large-scale web services, and for mobile editions, for mobile devices or embedded, you can go with the Java ME versions. Okay, right? So the Java FX is also there for the interface designing. So this is how the JVM architecture looks for the people. JVM processes Java program through a structured pipeline, from loading bytecode to executing in an underlying hardware. First, the class loader comes into picture. Then there's the Java will be class loader. Then the execution engine. Then the runtime area, that is your JRE. Then your native interfaces comes into picture. Each stage plays a distinct role. The class loader brings code into memory. The execution engine runs it. Runtime data areas manage memory, and native method interface connects Java to the host systems. So the four levels where your JVM is going to work: loading, execution, runtime environment, and the memory management, which is going to happen in the native interface methods. Okay. Next. So in this sessions, the questions, what you need to understand is that what is JVM and what are the main tasks? JVM stands for Java Virtual Machines. Its main task, as we saw here, it has to load the file, execute the files, it has to manage the memories, and has to give the proper interface to host the systems. What is JRE? JRE is a Java runtime environment. It's a collection of libraries. And okay, JDK is nothing but JRE plus the JVM. Key components of JVM architecture, as we saw here: class loader, execution engine, runtime areas, and native interface. How many types of class loaders exist in Java and how do they work? I would request you people to do some research on these questions, 5, 6, 7. Okay, what is the difference between the interpreter and just-in-time compiler? What are the key difference between JRE and JVM? So this is what we are going to learn in today's sessions. Thank you very much.